Hi class, and welcome to 6.5 notes. These notes are on the quadratic formula. So the quadratic formula is another way to solve for x in a quadratic equation. So far there has been 3 different ways that we have solved for x. The first way was by factoring. Factoring is an excellent way. It's easy, it's quick to solve for x. However, it doesn't work in every case. Another way that we learned is by using our graphing calculator. That was way number 2 that we learned. Also a great way to solve for x, or to find the roots or the zeros of our function. The third way we learned yesterday was completing the square. Completing the square is a little bit more time consuming, as you found out yesterday. You're going to find that for tomorrow's lesson. Is there an E in completing? I don't know if that looks right or not. Please don't correct me if I'm wrong. But the third way we learned was completing the square. You're going to find out in tomorrow's lesson that completing the square is very, very valuable for other reasons. But for solving for x or finding the zeros, it's maybe a little bit more monotonous, a little more tedious. However, it does work. So now we're on number 4, which is completing the square. There's several things nice about completing the square. Oh, not complete the square. Number 4 is the quadratic formula. That was dumb. Today's lesson, quadratic formula. So, the benefits of using the quadratic formula. One is that it's pretty simple to use. All you need to know is this formula right here and what those letters mean, and it's very, very simple. Another reason why the quadratic formula is so nice is that it works in every single case. It will work with double roots, it will work when you get 2 roots, it will work when you get imaginary roots. It doesn't matter, the quadratic formula is going to work every time. So there are some benefits to using the quadratic formula. Another reason, it is pretty quick as well. So we'll have 6 problems on that. We'll go through those now. The first thing that you need in the quadratic formula is you need it in the form ax squared plus bx plus c equals 0. Meaning we have to get everything onto the left side because we have to get a 0 onto the right side. So that's different than completing the square. Completing the square, we want the constants on the right side. But for the quadratic formula, everything goes on the left. So let's subtract 28. X squared minus 12x minus 28, that equals 0. Now, just as I taught you in the video lesson on how to factor the sum and difference of 2 cubes, I told you that the very first thing we should do is we should label what a and b are. In this case, we should label what a is, what b is, and what c is. Because once I label those 3 numbers, all I have to do is put it right in my formula. So my value of a is the number in front of x squared. It's my coefficient in front of x squared. In this case, it's an understood 1. My b value is the value, or is the number rather, the coefficient in front of my x variable. So that would be a negative 12. Here's a, here's b, and my c is my constant term, which is a negative 28. So now class, once I've recognized what the 3 letters are, the rest is quite simple. All I have to do is put it into that formula that was developed for me. And this formula works in every single case. So, a negative b, I'm going to write down again here, x equals a negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Class, this formula will be given to you on a test. It's also on a poster in my room. So if you're ever doing homework in my room, you could look on the poster. But it's very valuable just to memorize it. X equals a negative b plus or minus square root of b squared minus 4ac all over 2a. So it's not a bad idea to memorize that either. If you want to maybe put it on a piece of paper and tape it above your bed so that every time you go to bed at night, you see that as the last thing that you do in the day and the first thing you do in the morning when you wake up, that's not a bad idea. Not that any of you are going to do that, I'm sure. But anyway, moving on. X equals the negative b. So the opposite of our b value, the opposite of a negative 12 is a positive 12, or a negative negative 12, which is a positive 12. Plus or minus the square root of b squared. b is a negative 12. That squared minus 4 times a, my a value is 1, times c, my c value is a negative 28, all over 2 times a. And 2 times a is 1. So now, class, once we simplify this in red, we are done and we found our roots. So let's simplify this. X equals 12 plus and minus the square root of a negative 12 squared is a positive 144. This negative 4 times 1 times a negative 28. A negative 4 times a negative 28, that is 112. So now this whole green part is now a positive number because a negative times negative is a positive. So now it's plus 112. Some teachers, I think, like to have this negative sign last and then multiply this times this. I kind of like to say it's a negative 4. I like to do this green box first, so it's the negative 4 times these ones, and then I just use the appropriate sign. If this gives me a negative number, then I put a negative number right here. If it's a positive number that comes out here, I just put a positive sign right there. So I think that's what works the best for me. All over 2 times 1, which is 2. So now simplifying the radical, 144 plus 112, that gets us 256. So x equals 12 plus and minus the square root of 256 divided by 2. Simplifying the radical, what is the square root of 256? Hopefully you say it is 16. So x equals 12 plus and minus the square root of 256, which is 16 all over 2. So we have two different answers for x. As you know, it's a quadratic, and quadratics always have two solutions. So one of them is going to be x equals 12 plus 16 divided by 2. And the other solution is x equals 12 minus 16 divided by 2. So 12 plus 16 is 28. 28 divided by 2, x equals 14. There's one of my answers. The other one, 12 minus 16, is a negative 4. A negative 4 divided by 2 is a negative 2. I have two solutions, x equals 14 and x equals a negative 2. And now, class, you could circle your answer and move on to the next one. If you would like to, before moving on to the next one, you could certainly check your work. 14 and a negative 2 are answers that you found that satisfy our solution, our equation back up top. So if you want to put 14 and negative 2 back into this equation and see if 28 on the left equals 28 on the right, you could certainly do that. Another thing you could do is you could put it into your graphing calculator, and what you have found is the zeros of our equation. My graph is going to cross at 14 and a negative 2 if I did this correctly. Let's take a look at our graph. Here's 0, 0. It should cross at a negative 2. There it is, crosses at negative 2, and it should cross at a positive 14. Here's 5, 10, 11, 12, 13, 14. So as you can see, there's a couple different ways that you could check your work. All of these previous ways that we've talked about all solve for x. They all get the zeros of the function. The quadratic formula is just another way. Now that I've done number 1, you guys try number 2 on your own. Pause the video. Let me know what you come up with. X squared minus 8x minus 33 equals 0. So your a value is 1. Your b value is a negative 8. Your c value is a negative 33. So when you put it into the quadratic formula, it's a negative b, so a positive 8, plus or minus the square root of b squared, which is 64, minus 4 times a times c, all over 2 times a, which is 2 times 1, which is 2. So now what I'm going to do, and hopefully what you did as well, is you multiplied the negative 4 times the negative 33 right here. So you would get 8 plus and minus the square root of 64. A negative times a negative is a positive. A negative 4 times a negative 33 is a positive 132. All that over 2. So now simplifying this radical 64 plus 132 is 196. So we have in our next line 8 plus and minus the square root of 196. All of this equals 196. The square root of 196 is 14. So it's 8 plus and minus 14, all divided by 2. So two different answers. X equals 8 plus 14 divided by 2, and x equals 8 minus 14 divided by 2. 8 plus 14 is 22. 22 divided by 2 is 11. 8 minus 14 is a negative 6. A negative 6 divided by 2 is a negative 3. There's your two answers. X equals 11, as well as x equals a negative 3. We're going to put this into our calculator, and we should get our parabola crossing at 11 and a negative 3. Here's your 11. 5, 10, 11, and here's your negative 3. 1, 2, 3. All right, and here's the beauty of the quadratic formula. Wait, I'm getting ahead of myself. Number 4, we'll see the beauty of the quadratic formula. Number 3 is just another example. Let's try it all together. Our A value is 1. Our B value is 22. Our C value is 121. So a negative B plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, we got some simplifying to do here. A negative 22 plus or minus the square root 22 times 22. When you do that in your calculator, you should get 484. Plus and minus the square root of 484. And then we have this negative 4 times 1 times 121. That is a negative 484. If you multiply these three together right here. All that is divided by 2. So underneath the radical, you have 484 minus 484. You get the square root of 0. Or a negative 22 plus minus square root of 0 is just 0. So it's a negative 22 divided by 2. This one is very interesting because all you get is x equals a negative 11. Because you don't need this plus and minus anymore because 0 is neither positive nor negative. It is just 0. So x equals a negative 11. Class, in a quadratic, are you ever going to get one answer? The answer to that is no. You're always going to get two roots. So if you only get one like this, it is a double root. And what does that double root tell you about the graph? That double root tells you that it's not going to pass through the x-axis. It's just going to touch it at that negative 11. It's going to go down and down and down, and it's going to touch the x-axis, but not go through it. It's going to touch that negative 11 right here, and then it's going to go back up again. So that's what that double root tells you. All right. The first three, problem 1, problem 2, problem 3, whenever you get a rational answer, those are integers, and integers are rational. Or if you were to get a fraction, you can get fractions in the quadratic formula as well. Whenever you get those for answers, it means that the equation can be factored. If you look at number 1, x squared minus 12x minus 28. X squared minus 12x, did I say minus 28? Minus 28 equals 0. Whenever you get rational zeros, it means that it can be factored. So I didn't need to use the quadratic formula on this one if the directions didn't specifically say, because this one could be factored. I would factor this into x and x minus 14 and a positive 2. And then I would set each of these factors equal to 0. X minus 14 equals 0, and x plus 2 equals 0. So then x would equal the positive 14, and x would equal the negative 2. As you can see, that's what we got up here. So it doesn't matter if you factor or use the quadratic formula, you still get the same answer. So you might ask, Mr. Berge, why do we need to use the quadratic formula when factoring is so much easier and it's so much faster? The answer to that question is problem number 4. Problem number 4 cannot be factored. You can try and try and try until you're blue in the face, and it will never, ever, 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 ever be able to be factored. However, you can use the quadratic formula and still get an answer. So that's the beauty of using the quadratic formula. So let's do it again. A equals 2. B equals 4. C equals a negative 5. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Once you simplify this, you found x all by itself, and you have thus found the solutions. So negative 4 plus and minus the square root of 16, all of this equals a positive 40. All of that divided by 4. So now we have to simplify the radical. This whole radical here becomes the square root of 56. So negative 4 plus or minus the square root of 56 all over 4. So as you can see, this is our first one where our radical has not been a perfect squared number. So if it's not a perfect square, such as 56, what we have to do is we have to reduce that radical. I cannot take the square root of 56. However, I can take the square root of 4. And 4 multiplied by 14 is the same thing as 56. So what can I take out of this? I can take out the square root of 4. It's a 2. So now I have a negative 4 plus and minus 2 square root 14 all over 4. Now if you were to circle your answer right here, I would give you credit, but I wouldn't give you full credit because you have not reduced. You must reduce as far as you can. Because this is all over 4, you have to make sure that all 3 coefficients can be reduced if you are able to. And as you can see, they're all even numbers, so they could all be reduced by a factor of 2. So now it's a negative 2 plus or minus the square root of 1 square root 14. This 2 right here, I said that wrong. This 2 becomes a 1 because you divide by 2. And you still have the square root of 14 all over 2. So there is the 2 answers that I want for this problem. X equals a negative 2 plus and minus the square root of 14 all over 2. Now I want you to be careful on this one because Excel Math, they might write their answers in a different way, such as they might write their answer like this. I'm not sure if they will, but it might be a negative 2 plus and minus the square root, a negative 2 plus and minus, not plus and minus. Sorry class. What I meant to say is they might, Excel Math just might put it into 2 different ways. So might have a negative 2 plus the square root of 14 divided by 2, as well as a negative 2 minus the square root of 14 all over 2. So just be prepared for that. On a test, I would say just write this one. For problem number 5. Number 5, as you will see with our answer, we're going to get something kind of unique again. And once again, number 5 cannot be factored. So that's the beauty of using the quadratic formula. We have x squared minus 4x plus 13, that equals 0. So my a value is 1, b value is a negative 4, c value is a positive 13. So we have a negative b, so a positive 4 plus and minus the square root of b squared minus 4 times a times c all over 2a, which is 2 times 1. Oopsie. So when we're solving this one, a negative 4 times 13 is a negative 52. So we have 4 plus and minus the square root of 16 with this negative 52, so minus 52 divided by 2. And when you take 16 and subtract 52, you get a negative 36. So this is where this one becomes unique again. 4 plus and minus the square root of a negative 36. That number divided by 2. Now, you are unable to take the square root of a negative 36 and get a real number. We get imaginary numbers, because this breaks up into the same thing as 36 times a negative 1. So don't leave your answer as 4 plus and minus the square root of a negative 36. You can take the square root of 36 and get 6. So it's 4 plus and minus 6. And you could take the square root of a negative 1 as being an I. So it's 4 plus and minus 6i divided by 2. Now remember, you need to reduce whenever possible. So because all of these coefficients are all divisible by 2, this becomes 2 plus and minus 3i divided by 1, or just 2 plus and minus 3i. So if you take a look at this one, whenever we get imaginary roots, such as this one, 2 imaginary roots, our graph does not cross the x-axis. So that's another good check that you can do as you're graphing these. If we look at the graph of this one, the x-axis is right here, and my parabola does not go low enough to cross the x-axis. So that's where we get imaginary roots instead of real roots. So you guys try number 6 on your own. Pause the video. Try number 6. You're also going to get imaginary roots for this one. You'll have to take the square root of a negative number. Unpausing the video. A is 1. I suppose I probably should have started here. To put it into standard form, x squared, you would subtract the 6x plus 13 and make sure you put it in descending order, because that'll change your a, b, and c values. So your a value is the number in front of x squared, your b value is the number in front of x, and your c value is the constant term. So make sure you're very careful when doing that. So we have a negative b plus and minus the square root of b squared minus 4 times a times c all over 2a. So a negative 4 times 13, we're now simplifying the radical. When we multiply those, we get a negative 52 again. So we have 6 plus and minus the square root of 36 minus 52 divided by 2. So under the radical, we get the same thing, or not the same thing rather as the last one, but we get 36 minus 52, which is a negative 16. So it's 6 plus and minus the square root of a negative 16 divided by 2. And remember what the square root of a negative number is. It's imaginary. So the square root of a negative 16 is 4i. That divided by 2. And then don't forget to reduce. So x equals 2 different roots, 3 plus 2i and 3 minus 2i. That should have been your answer for problem number 6. So for your assignment for tomorrow, there it is. We have objectives 82 and 83. Please be very, very sure of yourself when you do these problems that you label what A is, what B is, and what C is. And after that, the discriminant, I probably should have stressed that a little bit more. The discriminant is the value underneath the square root. So it's b squared minus 4ac. make sure that you're very careful when you simplify the discriminant, because that could be a spot where it slips many people up where they make mistakes. So ask me questions if you have them. Objectives 82 and 83 is your homework.